Welcome to Next In, where we speak to entrepreneurs, we talk to intrapreneurs, and everybody that's on the journey to level up their career and get to the next level. And today we have Kumar from Turing Labs as the CTO. Welcome, and thanks for joining me today, Kumar.
Thank you, Shane. My pleasure.
Yeah. So we were just talking a few seconds ago about a conspiracy theory, and I wanted to get your thoughts on it. But you were doing some interesting research earlier today. Do you want to tell me and the crowd and the millions of followers that are on here what you're following right now? What's the local news?
Well, yeah, I was talking about the Polaris Dawn mission that I think I forget the name of the person who started it, but it's through SpaceX, and they are flying the SpaceX capsule up to the highest point that's ever been outside the Apollo missions, and so it goes up to the Van Allen radiation belt. And one of the conspiracy theories around the moon landing is that humans cannot go through that radiation belt and survive. So this, I think, would be the final nail in the coffin. If these people they're going to open up the hatch, they will let all the air escape out and let the vacuum of the space come into that module in the middle of the belt, if I understand it correctly. And so, if they survive, then we know that particular part of the conspiracy theory that humans can't survive that radiation belt would be debunked. And so, I guess we're closer to establishing that the moon landing did happen.
So what are your thoughts? What is Kumar's prediction on whether or not the moon landing happened?
I think it did. There's too much technology that came out of that decade and subsequent efforts that it's well, actually the biggest thing is that since then a lot of countries have been able to send probes up, different kinds of spacecraft. So it makes a lot of sense that it's doable. And then even just as part of my research, I was looking at how the process happened, and they were Apollo 1, 2, up to 15 or 16, and the first 9 or 10 were just progressively getting closer to the moon. And so if you had to do a conspiracy, why would you go through the effort of 10 launches to get to the 11th success? If you just wanted to fake it, you could just say, there's the first one and we were there. That whole process of this development mechanism of, what's the next milestone? Let's hit it. Let's get to it. Then do the next harder one. And you learn at every step and you fix the bugs and the errors of the previous step. That seems to be how you would actually do anything that's really hard and unknown. And so, if you had to fake it, you might as well just say, yeah, we didn't. And, we kind of shot the thing, and it's Apollo 1 is the same as Apollo 11. Why go through the pain of, 11 years of doing research in the public?
You're like, it's been one giant joke. We've been banking on it. We've been waiting for people to actually do it. If we plant the seed that it's possible, maybe it is. And then all of a sudden we live in a world called Dune. And we're chasing spice for the rest of our life. Well, part of what I want to get into, Kumar, is obviously you've had a really successful career, and you're well educated. You went to a few decent schools. That a lot of people would dream of, whether that's going to Columbia or being a part of Northwestern's Kellogg program. You've worked at Microsoft. But before we get into becoming the CTO, because you've been a CTO at Turing Labs and you've been the CTO at multiple other startups throughout your career after leaving, wildly successful careers internally at other jobs. I want to know where that itch came from, though. Where did that get started? You're the CTO today. We're talking space. We're talking, did the moon landing happen? Did it not happen? Did that help inspire some inspiration? Maybe it did, maybe it didn't. But I'd love to go down to the base level of how did you even get started into this idea of I want to be a computer scientist. I want to be an engineer. I want to, hack the internet. Where did that start?
Yeah, it's a good question. It was, I think it just started with, it just so happened that, when I started my career, the internet was really getting to be, come close to its potential of, it wasn't that big yet, Google was still pre-IPO, but it was starting to, you could start seeing this huge leap of capability that came from just having access to information.
Yeah.
And
I don't want to interrupt you, but I want to even take a further step back, right? Where did you grow up? Where are you from?
oh yeah, I was born in India, in Delhi. I was there till I was about 15. Then I spent a couple of years in West Africa, in Ivory Coast. I got introduced to the US, the American school education system from there. So that made me, apply to colleges in the US for my undergrad. I landed at UMass Amherst in Massachusetts. That was my first time to the US.
What was that process like? Because you were in India, you were in Delhi, then you went to the Ivory Coast. But how did you get to the place where you're like, I'm going to go to school in the US? Because from my understanding, it's not an easy task from where you're from, right? Like there's a lot of people that want to do it, but there's not a lot that's like 1% of the people that want to do it actually end up getting to do it. So how did you make that happen? Because that's a pretty big deal.
Well, so I think the move to Ivory Coast was kind of took care of that, because when I landed there, there are two schools for international people in this city called Abidjan in West Africa, on the coast of Ivory Coast. There's a French school and there is an American school. The French school follows the IB education system. The American school had the APs, and then kind of make it easy to apply to colleges in the US. So I was in the American school. It was interesting because this was my first time out of India, and suddenly you are in this school that has 300 kids. That's it. The entire school, starting from, I think it was like first or second grade up to high school. 300 kids, a very small school, but it represented some 80 different nationalities. So I come from India. I've never interacted with anyone that's not from India, and then suddenly you're placed in this, you're this kid that is like, I have this, I've never met anyone from outside, and suddenly you're getting exposed to 80 different cultures at the same time. It's like a big shock, and it's one of those, looking backwards, it was unintentional and not on purpose, but it was that point of growth, just putting yourself in a space where suddenly you are forced to grow. You're forced to learn how to interact with people. You're forced to tackle with problems that you've never faced before. Ivory Coast is a French-speaking country, so for me to go out and buy a sandwich on the street, I had to pick up that the broken French I need to just communicate. Or if I had to take a cab to school, or I had to go, so you suddenly you put yourself in a situation that causes you to grow, willingly or unwillingly. And then that was actually my first exposure to that kind of exponential growth that happens in your ability to learn ideas, learn concepts, and start applying them immediately. But then it's an American school. I went in, I started taking some AP courses, and when the time came to decide what to do, it was very easy, because everyone around me, because they all had made the choice that, is it the French school that goes into the UK, Europe type of education system, or the American school that goes in the US, Canada type of system. Everyone had already made that choice. So it was very natural that, that's what you do. I did consider going back to India for graduate school or undergrad initially. But it just seemed like I was in this system that would take me to some nice colleges that I'd been researching, and it was worth the shot. So I gave it a shot. I think I had a few choices, and I ended up on UMass Amherst. Again, it was I was going from tropical rainforests in Ivory Coast to the negative 20 degrees of cold in western Massachusetts. That it's just like 6 months of snow. Huge change again. But that's how I and that was in hindsight, it feels, I think that was the takeaway was putting yourself in a situation where you are forced to grow, you're forced to learn something. And that's been sort of the theme, and really the reason why I was at Microsoft for quite some time. sort of getting used to the life of a bigger company at that time. And when the first software I worked on was an 18-month release cycle. And this was when waterfall was the norm, and you did things slowly. You take like 4 months of writing specs and gathering requirements, and then 4 months of development and 4 months of testing, and then you release something. And so right, a different way of working, a different world. But I got the chance to work on this software. Uh, this is a safety software that would deploy antivirus signatures on PCs running that security software globally. And one of the first projects I had to do was uh, set up a mechanism such that you could a web service that would push out updates to all these millions of PCs globally, so that they could all be upgraded to the latest antivirus signatures and then be protected. And I'm a junior engineer, and I said, yeah, you send a message to all the PCs that, hey, time to download. And just in our internal setup, so, all these PCs wake up and they start downloading stuff from this service in one of the Microsoft data centers. And you realize, oh, you can't do that. You can't let every PC come at the same time and say, I want to download this, 10, 20 megs of file, because it brought down the service. And that was my first experience with what distributed compute would be. How do you plan your services? How do you stagger releases so you don't bring down your service? Essentially, what I did was created a denial of service attack on the service itself. And it was my service, so I wasn't even trying to attack it, but ended up attacking it. And so, things like, how do you ensure that you have enough, you do load balancing, you break up the group into groups, your population into groups, so that they can come at in a more controlled manner to get the service that they need. And all of these concepts became, how you design scalable web services eventually. It became very useful. It was a good early lesson again in understanding that. But after that, I was in Western Pacific Northwest in Microsoft headquarters. I moved to the Bay Area, joined a startup there. It was called Apogee, that was eventually acquired by Google. And, again, got my first, it's one of those things, I had no reason to move. Microsoft would have been Microsoft had really good career paths, and you could stay there, and, you put in your time, and eventually you grow, and you can do what you want. You can pick, from many different types of jobs you could do within Microsoft. You essentially have the entire spectrum of hardware to software, compute to distributed services to local, client software. But I said, that's great, but why not try something else? So moved to this company. That was the new thing at that time that Apogee really popularized was APIs, and this whole concept of creating this layer that can provide service to all different types of shapes and sizes of clients. I moved to the Bay Area for that, and then since then I've been, in different types of startups, and it's really that same. Now I do it purposefully. I try and get into to situations and jobs and roles where one of the three things that you need experience in a domain expertise. You need expertise in, at least for me, it's building software. And then you need, expertise in that environment, that way of operating. And what I like to do is, I have some expertise in building software. I have decided that I like smaller teams because I like not having to more and more. It's more fun for me to build software and focus on that rather than managing a very large team. So I did that for a bit, and then I realized I don't really enjoy that. I really enjoy building software with a small, agile, nimble team. And so what I do is I try and jump into domains that I have no clue about when I jump into them. And so I've been doing that for the last 3 or 4 roles. And I keep the other two things constant: small teams and for using software to solve the problem. And then what I keep switching is just brand new domains and
Interesting. So I want to pick that one back up here in a second, but I do want to back up for a second, which is like you kind of blazed through the fact that you went from Microsoft and you got into multiple leadership roles, you got promoted multiple times, and there was like these things that allowed you to take on more responsibility. Now, you do say that you got promoted, you ended up having big teams, and then now you wanted to rally down and go to more smaller, nimble, agile teams. And I have to imagine that there's a lot of people that feel or have felt or will feel that exact same way eventually. So, if you're one of those people, I'd love for you to drop a comment or, say something or ask a couple of questions that we could get back to, in the future. But one of the things that I want to know is, how did you get promoted? Like, why did that happen? Like, obviously there's multiple, whether that's, jumping from one school to another, whether that's going from one culture to another, one natural environment, going from, hot weather to cold weather. Like, there's all these things where like you've naturally put yourself into situations to experience something different, which is obviously a unique superpower that you've been able to develop over time. But what are some of the things that allowed you to level up and start getting promoted? Was it because of a philosophy? Was it because of a mentor? Was it because of a chip on your shoulder? Like, what inspired you to be able to rise through the ranks? And then what do you really believe allowed you to get there?
Yeah. I think it took me some time to understand that lesson, but I think it's growth comes from being able to step outside of your own self and look at yourself and say, okay, I did a task, I accomplished a goal. But if I were to, how would I do it better, or how would I do it as if a senior engineer had done it, or how would I do it if a technical fellow had approached that problem. So being able to see, if doesn't matter if you can accomplish goals, but being able to visualize how would somebody else that solved that problem multiple times, how would they approach the problem. And the one and again, this came through trial and error, or really just learning by not doing it enough times and then realizing that I'm not able to grow. Eventually it clicked in my mind that you have to be able to see what you did from a perspective of someone that's done this before. How would someone that's done it before approach that problem, or that solution, or that design? And the way to obviously people say that, and this is what I found true. I mean, I was able to do it because of people I talked to, officially or unofficially, who were mentors, who helped me see either a different way of looking at something, or or explaining that I had to do that. That just being aware of the fact that you have to be able to see what you do, right? So there's a saying that say that don't wait for the next job to do your best job, right? Do it in that job. But the way you do your best job is not just by accomplishing the task, but getting better at solving the same problem differently, in a more efficient, a better, simpler way. And there was a project I had done, and this was at Microsoft time, where I looked at a user is in a particular state, and then if they go to this other state, if they want to go to this other state, how do we get them there? And I had this complicated software that said, if you're in this state and you want to go here, then you do this. If you're in this state, you want to go here, you do this. And then when I came to the second version of that same software, I realized that I actually don't need to worry about where the user is at any point. If I know where they want to end up as, I just need to focus on that problem. It doesn't matter where they are, because it's really about getting them to the next state. And so what came out of that is a very simplified software that just said, here is how you get to this state, and I just make that happen. I didn't need to have this complicated if then else loops in my software. And I came across that because my manager at that time asked questions that made me realize the patterns that, it doesn't really, what I do to get the user into the best state has nothing to do with where they are currently. So why even bother looking at that? I can just go directly. I can just make that happen in the software. And this was because of those discussions that I had. So I think finding mentors that can help you look at something in a slightly different way, that forces you to, or they can help you understand how to approach a problem differently, or approach it as if someone that's more senior would do it. Just being able to play those scenarios in your mind and say, okay, how would I solve that problem today? I solved it 5 years ago, but can I do it? If I did it again, would it be different? That's how I think forcing yourself that's how I feel you can induce growth in your own.
Interesting. So finding mentors, tell me a little bit more about that. Like, what was your approach to find people that like, how did you find people? Like, it's, I think it'd be really easy to go, okay, go find a mentor. And somebody's like, yeah, rally the troops, find a mentor. And then they're like looking around and they're like, okay, what do I do?
Yeah, it's hard. It's hard to find. And I think if you start off by saying, I'm going to go find a mentor, it doesn't really work that way. You can't just say, I'm going to find a mentor, and then you end up finding it. I think it happens over time. I think it happens being curious with people. Just everyone interacts with people all the time, and I think one of the principles that I've always followed is that there's always something to learn from everyone. And then some people, you realize that there's more to be learned from them. And as you try and do that, that can develop into a relationship where you can trust that judgment or that feedback, and that becomes a mentor-mentee relationship. But I think, looking at generally what I'll try and do is, okay, why would someone do this in this manner? And is there something that I could learn from it? And when you realize that you can actually learn something, you will naturally start asking or looking for that person's as an example to do what you're doing, or to approach what you're doing in a different way. And that can become that relationship. I think sometimes if you find a really good manager, you might change roles or jobs, but they continue to be a source of wisdom for you, or someone to help guide you. That's one way of so on one extreme, you don't want to burn any bridges when you change jobs. But if you have a good someone that genuinely cared for your career or your growth, they're always a good source of being to stay in touch and bounce ideas forward. And I do that. I've found some really good people over the years, and I will go back and I'll ask them for advice. I will ask them for how do you measure a situation so that you can make a decision. How do you make a decision, a better decision, a particular situation that maybe I haven't ever dealt with making that type of decision, or maybe I have, but maybe I'm missing the certain inputs that go into that. So I think that's probably the best way to do it. I think large companies will have programs where they'll try and match people inorganically. I'm sure they can work. Sometimes they can work, but
I think Microsoft calls them passport programs. I remember it when I was internally at Facebook. It was always like global passes where you fundamentally between teams and whatnot. So let me ask you this: when we're talking about like making choices and making decisions, like I have to imagine not all of your decisions have been perfect. We're flawed. We're human, right? Can you remember a time, maybe a time that you don't like to admit to, where it was like a major failure? You're like, this was like a really embarrassing moment for me, but it was such an embarrassing moment, or it was such a big failure that it left some battle scars, maybe some road rash, but it was something that allowed you to grow and really picked you up. Like, can you talk about that a little bit? Like an embarrassing moment or a major failure, one that you don't like to admit to, but you're like, but it's who I am. Like, this is baked into what Kumar is today.
It's fine. Early periods of any career are the ones where you make the most mistakes, and that is the time to make mistakes. I mean, that's if at a point you prefer making mistakes, it's early on in the career. And so I keep going back to, like doing the denial of service attack on my own service. That was an example. But I think the focus on quality of software. I mean, in any profession, it matters. Quality matters, and I think we're sort of lucky in software that there's a higher tendency to, or a higher resiliency to quality, lack of quality in software, just because but if you're building yeah, EKG machines or MRIs or something, and the bar is much higher. Or building software for navigating a SpaceX module, the bar is very high for quality. But that lesson that quality matters and what you can do should be done is the lesson that if you don't do it right, you pay 10 times more price to address it later on. And one of the instances I was in a fairly large team at Microsoft at some point. I would say about would have been at least 500 people. And as an engineer, you would write your code, you would write your unit test, you would confirm that you've tested it well, and you would check it in so that the build could be done. And then the next day, everyone comes in, updates their code base, deploys the latest build, and they start working against it. And I remember at some point early on, I broke the build. I checked in something that assumed that I'd been testing my code against a clean machine. So it used to depend on registry entries, and I would start with a clean machine. So the entries were, or I did not start with a clean machine. I started with my previous state where I already had what I expected. And so my code looked for it, it would find it, and I said, oh yeah, my code works. I check in the code. Next time, it gets installed on a clean machine for everyone, some 300 people. None of them have that registry entry, and everybody's machines, the software crashes on everybody's machines, and nobody can work for, I think it took like 6 hours to kind of understand what happened and then fix it. So I was responsible for 300 people not doing anything for 6 hours. That's a big productivity loss. And and it was not an infrequent occurrence. It would happen. So our team used to have a dunce cap, and you had to wear that hat all day. And I broke the build. They would say I broke the build. But that was, and again happened. And I think to the culture at that time, and I think in any good culture, the team was that, look, it should not happen. You shouldn't have done it, but it happens, right? It happens to everyone, and you learn from it. So
talk about that for a second, a little bit too. Is just like it's an interesting thing to point out, where you're like, it happens, you made it happen, but like by having that hat that said I broke the build, how do you think that empowered the team?
What you want is, it's like training a machine learning model. Yeah, you have to have negative examples, and you have to have positive examples. Right? Positive examples reinforce you. Negative examples, it's the carrot and the stick. So you want to ship fast, and you want to check in code fast, and you want to build awesome features, but you want to do it in the right way, and you want to do it in a way that it doesn't actually slow things down. So the speed I got because I didn't check that particular edge case maybe saved me 20 minutes. Right? I could have done it in 20 minutes. I didn't. That test case would have taken 20 minutes to write. But then skipping that cost the team 300 times 6 hours. Right? That's how much productivity was lost. So I think it becomes a reminder, right? And even right now, randomly, I mean, we're on this podcast, and it's one of the questions you could have asked, and you asked this question, and that's the thing that comes to my mind, that, oh, that's where I learned my quality lesson, that the right time spent at the right time is worth it, right? You will reap the benefits, or you'll pay the price if you don't do it in the right way. And that was one of those lessons that it doesn't haunt me, but I always remember now when I'm working with the team. I use this example quite a bit, and examples like this where I made mistakes. I use my mistakes as an example to just impress upon the team the need for certain things and behaviors, so they don't have to. It's like the saying, you don't have to learn everything the hard way. But some things you should learn the hard way, because then those lessons tend to stick.
Well, that was going to be what I was asking, was just like, if you could go back and like snap your fingers, would you go back and change it and be like, hey, like I would have just wrote the 20-minute test? Or you're like, no, by not writing that, by wearing that hat, by feeling embarrassed, by costing 6 hours times $300, like that's a lot. That's a like, it's a little bit of a badge in my opinion, right? Like I remembered, I got fired by Belkin International one time. Like I was recruiting for them specifically for machine learning and engineers and data scientists. And it was my first 6 months in recruiting. And, I was sending them all these people with PhDs and did machine learning, but I didn't realize that I needed somebody that specifically understood salt and pepper noise and understood frequencies, because they were doing testing against water frequencies to understand where leaks were. And I was sending them all of this junk, but they just kept interviewing everyone. And I was like, I thought I was doing really good until they fired me. And they're like, Shane, you've wasted our time. And I was like, what do you mean? You chose to interview them? They're like, yeah, but we expected you to know what type of data scientists and what type of machine learning engineers we were looking for. So we were just going to interview anybody that you did. And there was a major lack of communication. And they were like, Shane, you're fired. And it was like the most humbling, embarrassing moment that I've ever had. Now, 3 years later, they became a client. We helped them, grow their Fin product, and it was awesome. But it like getting fired was like one of the best things that ever happened to me, because my ego was inflated at that time. I thought I was on top of the world. I was like, I'm doing amazing. And then all of a sudden they're like, nope, pulled the rug from underneath me and was like, you're fired. And I was just like, it blew my mind a little bit. And it was just kind of like that. If I just took 20 minutes to write this test and I asked a few more qualifying questions, or if I just set expectations a little bit better, like, hey, look at the resume and give me feedback. Like,
Yeah.
there's like little things that I could have done that would have improved my client's experience. But because of me, I failed. Because of you, code went down for 6
Yeah.
hours across 300 people. I don't think I would ever go back and be like, hey, I want to salvage that relationship. It's like, no, that the failure of that relationship allowed me to become better and become proactive and to understand how to think 5 steps ahead and to jump into the future. And it sounds like you would agree with that statement. And it sounds like you learned that lesson where it's like, no, if you're junior and if you're listening, it's like, go make those mistakes. Just do it once and just learn not to do it again. I think that's the big thing here, right? Which is make the mistake, feel the pain, carry the story, evangelize that story, and recognize that you can be a disciple of that story and pass it on to the next person, so they don't have to learn the mistake that you made, but you can become an evangelist to be able to carry that and then pass that through and to develop others in the future.
Yeah, 100%. And then the other side is that, as now that's someone who's responsible for, a team to develop high quality software. Now I can remember, I can recall my days and the team, the managers at that time, and their attitude on how they handle that situation, right? It's a very, and so then that's again a learning for me at this point, which I can apply, that junior people will make the mistake, and everyone gets to make it once, right? If you make it twice, there's a problem, and thrice, you shouldn't. You haven't learned anything. But we all make mistakes, and that's the only way to have really solid learning, is when you experience a mistake. So you want to make mistakes early on in your career or early on in any project. So asking the stupid questions is early on is the right way to handle situations where you're unknown. And so and that's kind of going back to the earlier question. I enjoy that now, to learn something new, to be able to say, well, I have no clue, and this is how, as a novice, I would approach this material, and teach me. And then I look around, for everyone who's willing to explain something so that I can learn something, and then I can bring on my experience and my value add. But for that, I have to be willing to say, I have no clue what's going on here. I don't understand this domain. But once I learn, I can apply a fresh perspective to it. And I feel that, um, anyways, most innovation, it looks at a particular field and applies the principles into a different field. And then the biggest example is, that nature is our biggest teacher in terms of, aircraft design to medicine design and so on. Like every field ultimately ends up learning from how the nature has developed these things over millions of years of evolution. That all those things have been figured out. I was just listening to Elon Musk talking yesterday on a particular conference, how they realized, I think for their robotics effort, I forget the name for what they're calling it, but the human arm has the muscles in the forearm that control the fingers through tendons. And they realized in their second version of their humanoid robot that they were putting all the controller, the actuators in the palm, and that doesn't work. It's too heavy. You don't get all the degrees of freedom or things like that. So in their second version, they're doing what the human body has figured out over millions of years of evolution, that you have to put it in the forearm and then just have wires to control the fingers. It's amazing, right? It takes a couple of iterations to realize that. But anyways, innovation is that you have to apply the principles, the first principles of a domain into something else, and you suddenly create new value and new opportunity.
Yeah, I always think of Picasso when Picasso says great artists steal, they do not copy. And so it's almost like that sort of that core principle, which is like you don't have to I don't like Picasso's art. I think it's trash, but people can argue all they want. But I love his principles, which is like this core fundamental of like, well, there are great artists out there that have already created something. So go look at them, use them, and apply that in your current work. So to your point, it's like why reinvent the wheel of where the mechanics should go? Like, don't do it here. We've already realized it should be here. So, like Picasso, it's like go ahead and steal from something that exists and iterate on top of that. And sometimes it's like people don't want to like listen to like, and they have to let some computers crash for a bit. And so there's like a lot of different examples that you can look. Now, I want to go into you a little bit, Kumar. Like, so obviously you're the CTO of Turing Labs right now. Help me understand, like, what does Turing Labs do, and what are you guys building?
Yeah, we're so this is. I was completely unaware of this whole industry, but consumer packaged goods industry. You make food and beverage items, you make household supplies, cleaning supplies, and so on. And something as what's the right word? But something as so common like ketchup. That when you start thinking about it, you realize that ketchup is so you say, oh yeah, it's made up of tomatoes and sugar and salt, and you put it all together, you get ketchup. But turns out that the entire process has a lot of variability. For example, I never connected these dots till I started working on this problem that tomatoes grow every year, right? It's a crop that's grown, and it finally clicked in my head. But I knew that from my experience, when you grow crops, there's no guarantee you get the same tomato every year, right? I mean, and you've heard this principle in with wine especially, right? So if you had a forest fire, the grapes become all smoky, and then the taste is off, or maybe good or better. But things that grow every year, like crops, they change their properties year over year. So the scientific problem for ketchup is how do you maintain that taste that consumers expect every year when your tomatoes, which is the core component, are changing every year. And that's a very hard problem because you have to. It's a very you can measure certain things. You can measure the viscosity, or you can measure texture, uh, but then you have to measure taste. And then so the way you do it is you do testing in a lab where people come in and taste things, right? And then you have to do that testing in such a way that you can maintain that quality, that consistency of taste and other properties. So it's a very hard problem, and this problem has to be solved again and again just to keep the product on the shelf.
Well, it's just kind of like if you go do a tour at Jack Daniel's down in Tennessee, right? You go to Jack Daniel's and you do the distillery tour, and then you come to find out that every single bottle is the exact same, more or less, right? Like they're all on a shelf. They're all sitting down somewhere, but depending on the light, depending on the heat, depending on the humidity, depending on the oak's contraction because of its natural environment, determine what quality level that whiskey ends up being. But at the end of the day, like all the ingredients are identical, but somehow because of the penetration or the density or whatever, it's like the taste comes out different. But you've got these premium bottles and you've got these like lower tier bottles, but like the end of the day, all of it's the same, to your point, right? And so like, how do you control that? How do you understand that? How do you make up that makeup?
And how do you make sure it's consistent year over year, right? Especially because like if you for whiskey, it's a good example because a lot of them are matured in uh, uh, wine casks, right? So barrels, yeah. So now if you've used a barrel for let's say 10 wine seasons, or let's say over 20 years, that barrel is going to have a different effect on the whiskey than something that's been used for 10 years or 5 years. It's so you have to set up a way to measure the properties of everything that goes in to creating that, and also that is used to create that. So we call them processing conditions. So the barrel is a processing condition because in a way, because it doesn't go into the actual uh, whiskey, but it helps make it. And then you have to have the right temperature and humidity and sunlight and all that stuff. And so what Turing does is it testing new formulations, which are combinations of ingredients processed together in a certain way. is extremely expensive for these companies. And because it has to be done in a lab, you have to test it for taste and quality and safety and a lot of different parameters. And so bringing a product to market or even just keeping the shelves stocked is a problem that CPG companies deal with constantly. And I had no idea that this is how complicated it is to get ketchup on the shelf. And so what Turing does is it gives you a faster, less expensive, higher quality mechanism to do this process over and over again. And so we collect data from past years and years of experimentation and building, and we train machine learning models that can predict how well a particular formulation is likely to perform in the test lab and in the real world. And then this is how we reduce the effort required to bring new products to market and then to keep existing products on the shelf. And it's a very interesting application of machine learning. But the biggest, what I really have grown to appreciate, and this is one of the things that I really, because I've always worked in, uh, you start with consumer space with digital products and services, and that's a whole different, you treat the problem differently, and it's a different way of building things. But as you get closer to things that the work you do, especially in the ML space, that manifests physically into things that people can experience outside of a laptop or a mobile device, it's a whole different problem area environment, and it's a different and the satisfaction of getting it right. It's different. I mean, I wouldn't say it's better or worse, but it's definitely different for me than something that you experience on a mobile device or a laptop.
So if somebody were to want to join Turing Labs, right? Like what is the mindset? What is the type of person that you would be looking for somebody to ultimately join your team?
Yeah, it's we it's a small team. We're all uh, what we need is people who are not satisfied with with the status quo. Generally, that's how I would summarize. Because we are, I mean, the nature of the problem is, this is how it's been done for the last 50 years, and CPG companies got big. So we are saying that there is a different way that's potentially more valuable for the customer. So obviously, the status quo of the current industry we feel can be changed. But what you need at a stage, at a size and stage of something like Turing Labs, are people who take problems personally. And what I mean by that is that you say, I see a problem in front of me, and I'm not going to sit till that problem is solved. And if that problem requires me to, talk to someone that's not in my immediate team, or even talk to someone, maybe I prefer working alone, but I need to, that you do what it takes to solve the problem. You're not satisfied by saying, I did my part, and this other person or team or process should have taken care of this. I don't know why I didn't. What you want is people who take ownership of the problem and are always in search for the next problem to solve. And that's really the attitude I feel um, you want in any situation. You That's what you want in a team, in your colleagues who you can then depend and trust that they will do what they can to solve the problem. So when something is not solved, there is a bigger you know issue that has to be thought through and addressed, because we know that everyone else would have done everything that they could do to solve that problem. So you want extreme ownership of problems is what I like. I think every other skill uh, can be learned. You can learn how to code in a different language, or you can even especially with machine learning, what has happened is that the amount of code you have to write become really small compared to when you used to be writing massive services. There are so many frameworks now that, and especially with not just Gen AI, but even no code, low code solutions that you had, you could string together a bunch of stuff really quickly. So it's
So
not
for you,
about
it
the
sounds
number
like
of.
it's not really about the technical chops. Like the technical chops are like an expectation. Like I expect you to figure this out. I expect you to be able to learn how to use the tools. Like if you need a hammer, you need a hammer. If you need a screwdriver, you need a screwdriver. But at the end of the day, the most important thing to you is like you need to have curiosity, step one, and then step two is you need to have the conviction to solve the problem. So it's like curiosity and conviction within the industry, where you're like, I need you to have purpose, conviction, curiosity.
Right. Yeah, it's an attitude.
Yeah.
And the attitude, that's the thing about, I think skills can be learned, right? You might be really unproductive the first month, first 6 months, 1 year, but the attitude of saying, I will not rest till I solve this problem, the attitude of extreme ownership, that cannot be taught. I think that comes with, or it cannot be imposed on someone. It comes from internally, because it changes the outlook. Because it's literally going from half empty to half full. It's that switch that happens mentally, that you say, no, no, yes, today it cannot be done, or it's hard to do this, but I will not rest till I can figure out something. And there's always a way to make something better. Sometimes the cost of doing something to make something better is not worth it from a business sense, but there's always a solution, or there's something that can be done to make the current state better, right? And if you're not able to see that, that's where the mentors help. If you can't see how to make something better, that means, because that's rarely the case that you cannot make anything better. There's always a way to do it. Sometimes you just don't see it. And sometimes it's not needed for the business. And that's a different problem. Being able to apply or do the trade-offs between the investment required to make something better, that's a different skill. But the attitude of saying, I will not rest till I make this better, unless someone tells me it's not worth it, right? Or I haven't found the solution that will make it worth it, right? Sometimes you have a solution, but it's not the one that makes sense from a business perspective. But I think that it really comes down to attitude, and that's what I would always recommend, is having the conviction and the passion to go after something and not rest. And when you do that, that attitude can be very infectious within a team, because it raises the bar. And it's not just that you solve bigger problems and you get rewarded more, but it gets everyone to feel. I think conviction is infectious, and it's the opposite of one bad apple ruins the entire basket. The opposite is, if you have someone really good and that's very passionate, that passion has to spread across everyone else, because people realize, oh, if this person is caring so much about what they're doing and they're pushing the boundaries, they must believe that something is possible that maybe I haven't seen. And people, so if either you're not, you're in the wrong place, so you don't really care about what you're doing, or maybe you are disenchanted or disillusioned, because you think that maybe the company is not going in the right direction, or the industry is doomed. Everything's tapering off. But when you see someone actually, have the passion and then actually make a change, you realize, oh, maybe my perception of my environment is flawed, and maybe there's more to it, and that pushes everyone else. And so it's a good way. I mean, that's what leadership is, right? Leadership is not having people report to you, but it's rather taking a problem and saying, we will solve it, and we will solve it in this manner, and this is what we will do to solve it. And you apply leadership to yourself. Can you lead yourself to solve a problem? And then eventually you can go and lead other people by identifying the problem and saying, this is what we will do, and this is why it's worth doing it. And that's how you grow in any career, I think. At least my view is that.
Amen. Couldn't agree more. So question for you, right? Are you actively hiring on your team today? And if you are, like, how can people get a hold of you? So what are you hiring for, and how can people get a hold of you if they're feeling inspired? And that could be a CPG company that's like, hey, like, Hidden Ranch, here we come. Like, we want to figure this out, right? Like, we want to make sure Hidden Ranch stays great, because we don't want to mess that one up, because I'm a daily consumer. But maybe I shouldn't be. But how can people get a hold of you? And what are you hiring for?
Yeah, we have TuringSaaS.com is our website. There's a form there. We're a YC company that was founded as part of the YC program. So, YC has its own ways of all the positions that we have. Primarily, it's either you're doing data science, you're you're a machine learning engineer, or you're writing application software. We want people in any of these three. We those are the main things that we're looking for. You can go to our site. You can, I'm on LinkedIn. You can reach out there, send me a message if something looks interesting. But that's what if you want to know how, these massive companies that impact billions of people every day through their products, how they become more efficient, this is the place to be.
Okay. So you heard Kumar. It's like reach out to him on LinkedIn. Go to the website, Turing Labs SaaS.com.
TuringSaaS.com.
There we go. Correcting me. And we'll make sure that's there's a link below. And if you're interested, click it, go view it, apply if it sounds like you're interested in solving those problems. But Kumar, I really appreciate you taking the time today. I know that the billions of listeners that are on here really appreciate you sharing your story and getting to hear how you got to become the CTO that you are today. It was a really inspiring story.
That's my pleasure. It's fun. Thank you.
I appreciate it. And we're looking forward to seeing how you guys grow. And for everybody listening, thank you for joining us today.